Okay, so today we're going to be talking about the second part of momentum. Okay, and I want to just start by refreshing okay, the meaning of momentum. The key concepts in momentum that we learned in the last class. Okay, the first one is that momentum is the product of mass and velocity. Hasil darab mass and velocity adalah momentum. Okay, and then after that we talked about the principle of conservation of momentum yang menyatakan bahawa the total momentum before any collision or any external force that changes the movement okay, will always be the same as the total momentum after the external force. Okay, but in the external force yang kita cakap dalam kes ini adalah berkaitan dengan collision, which in bahasa Melayu is called perlangkaran. Okay, so in our case that we want to talk about today, okay, I only want you to remember this. Okay, I find that it's easier to think about this rather than to think about which formula yang boleh pakai untuk apa. Because the formula yang boleh pakai untuk apa, okay, is really not helpful for me. Okay, it's confusing. So think about it in this way. The total momentum before the collision, okay, before any kind of pelanggaran berlaku, okay, must always be equal to the total momentum after the collision. Okay, remember before is the same as after, but it must be the total. Okay, it must be the total, not the individual momentum. Okay, and for our level, for Form 4 level, we only usually talk about two objects. Okay, kita pertimbangkan dua objek yang bergerak, okay, or two objects that collide with one another. Okay, either this way atau this way okay. So it's always two objects we don't talk about three objects, four objects, because that's a different calculation altogether. Okay, so we are only interested in two objects that collide. So the total momentum before is always equal to the total momentum after. Although the individual momentum, okay, dia punya momentum secara berasingan akan berubah. Okay, tapi jumlahnya tetap sama. If you are learning this in Malay, the principle of conservation of momentum juga dikenali sebagai prinsip keabadian momentum. Okay, keabadian abadi means dia always forever remain the same. Okay, that's what it means to conserve. So there are three types of collisions Okay, ada tiga jenis pelanggaran that we want to talk about. Okay, the first one is called an elastic collision. So before the collision, okay, let's say these are the two objects. Okay, object number one, object number two. So before they collide, they are moving separately. Okay, either they are coming towards each other like this, or they are they're like this Atau ini tidak bergerak, tapi ini yang jalan. Okay, so they are actually moving separately. And then after mereka berlanggar, boom, like that. Okay, then we find that they are still moving separately. Okay, this is very normal. Okay, this is very normal, and we will see an example later. Okay, so just to explain, an elastic collision, okay, atau pelanggaran kenyal, okay, in Malay Okay, the motion of both the objects after collision is they move separately with different velocity. We find that the original velocity and the velocity after they collide, after mereka berlanggar, is very different. Okay, but they move separately. That's the key thing. Itu yang paling utama about elastic collision. They move separately. Okay, the question is the momentum conserved? The answer will be yes. Of course, the momentum is conserved. The total momentum before they collide and the total momentum after they collide must be the same. Okay, atau dikenali juga sebagai conserve. Okay, must be the same. The word is conserve Is the energy conserved? Okay. This one, we will talk about this more next year when we learn about energy, but I would just want you to know this as a fact. Is the energy conserved? Okay, the answer is the energy is conserved. In an elastic collision, the energy is conserved. Is the kinetic energy conserved? Also is the kinetic energy is conserved. Why? Okay, these last 2 points, okay, I know that we haven't touched about kita belum lagi sentuh pasal conservation energy, but for now, I just want you to learn it as a fact first. Okay, in an elastic collision, energy and kinetic energy, okay, is conserved. Means the total energy before and the total energy after is the same. Because after this, we're going to look at another type of collision, di mana ini akan berubah sikit. But no matter which type of collision, momentum is always constant. That's the one that you need to remember. Okay, so this picture on the right side over here shows another example. Okay, it's the same thing, two balls that are moving to the right side. After they collide, boom, okay, the two balls are still moving separately. They're not joined together. Okay, this is an elastic collision. Okay, now I'm going to show you an equation which I'm going to ask you not to copy yet. Okay, not to copy yet, because I always find that learning this collision using equation is always very confusing and it's not very helpful. Okay, later when we answer a couple of example questions, I will try to show you a way that is easier for us to understand. Okay, so anyway, this is the equation lah. M1 U1 and U2 equals to M1 V1 plus M2 V2, blah, 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 blah. Okay, so we'll come to that in a while. So that's the first type of collision, okay, elastic collision, pelanggaran kenyal. The key thing about the elastic collision is after they collide, okay, they still move separately, okay, and there are many examples in real life that you can see this happening, okay. Now the second type of collision is called inelastic collision. Now if you look at the elastic collision begini, they move separately after they collide. Kalau inelastic collision, they move together after they collide. That is possible sometimes. Okay, and this one you see especially contohnya figure skating dancers. Okay, it's like when they do a duet kan, after they, after the skater comes and then they join together and then they dance together. That's an example of inelastic collision. Okay, so the biggest difference between elastic and inelastic is what happens after the collision. In an inelastic collision, okay, atau pelanggaran tak kenyal, okay, in an inelastic collision, after they collide, lepas pelanggaran, they will move together, okay, sort of join together somehow, okay, and they will move together. So the motion of both objects after collision, okay, is they move together with the same velocity. Kalau kita bandingkan dengan before, in elastic collision, they move separately and with different velocities. Okay, but in an inelastic collision, since they're moving together, obviously they have to move with the same velocity. Okay, dia punya kelajuan mesti sama. Oh, sorry. Okay, then is the momentum conserved? According to the principle of conservation of momentum, the momentum must be conserved. The total momentum before must be equal to the total momentum after. Okay, which we will come to in a while. Is the energy conserved? The energy is conserved, just like elastic collision. It is conserved. Now, this is another very big difference about elastic and inelastic collision. Is the kinetic energy conserved? The answer is no. Okay, in an inelastic collision, the kinetic energy is not conserved. Okay. Now, at this point, some of you may be asking me, and I can see that some of you are already privately asking me, why suddenly talk about energy? Okay, I know. Okay, I know that we haven't touched about energy, and actually energy only comes in the second year, next year only we're going to talk about energy. Okay, but I just want you to take this as the fact first. Okay, if you want a detailed explanation, I can explain it to you, but I'm not going to explain it in this class. Okay, you can ask me privately another day. But for now, I just want you to know the key difference between inelastic and elastic collision. Okay, there are altogether three differences. Okay, the first one, elastic collision and inelastic collision. Okay, the first one is in terms of after they collide, how do they move? Do they move separately or do they move together? Secondly, okay, are the velocities the same after they collide and before they collide? Okay, and then thirdly, is the kinetic energy conserved? Okay, we find that inelastic collision, okay, pelanggaran tak kenyal, the kinetic energy is not conserved. Okay, and the kinetic energy for elastic collision is conserved. Okay, so there are a few similarities and a few differences between elastic and inelastic collision. There are two similarities, dua persamaan yang kita nampak. In both collisions, momentum is conserved, total energy is conserved. Ini saja yang sama. The rest is different. Okay, elastic lepas pelanggaran separate. Inelastic lepas pelanggaran join. Elastic lepas pelanggaran the kinetic energy is conserved, but inelastic the kinetic energy is not conserved. Okay, so it's good for us to know the differences between the two collisions. Okay, but at your level now, okay, especially in Physics Form 4, I'm more interested that you understand the principle of conservation of momentum. Okay, because when we do the calculation later, okay, this is the formula. Okay, this is the formula for inelastic collision. It's very super long and it's very super, to me, it's very super nonsense. Okay, I feel that you don't have to memorize this formula because when you understand the principle of conservation of momentum, you can count it separately and then you will see that actually it's much easier than it looks. Okay, so don't worry about copying this yet. Okay, we will come to this in a while. Okay, I'm going to show you this video, but I'm really not sure whether you can hear the sound. So I'm going to just press play, and if you cannot hear the sound, well, just take a look at the picture. Okay, so, oh, sorry. Can you guys hear the sound? Can hear the sound. Okay, great. Okay, so this is an example of elastic collision. Look, they move separately. So, yeah. So when this is the Caillou that is hit, okay, so this is another type of collision. Also elastic collision. Okay, I'm just showing all these examples of elastic collision. So the ball moves, hits this ball for life, and then they move separately. Elastic collision. Look at the movement. Wow, look. Hebatnya dia punya very hebat. For life, and move separately. So another example of elastic collision. Okay, I don't know about you, but I'm very awake because of the music now. But okay, those are examples of elastic collision. Okay, that we can see. So every time something collides and then they move separately, all those are elastic collision. Okay, I'm going to show you another video. Yeah, I hope this one that will sound also work. See that the sound when the sorry for this horrendous face. So when the guy was, crashing into the car and they were moving, and the guy was moving together with the car, that's a sort of example of inelastic collision. The lorry was banging into the car, and then they were moving together, sort of moving together. So that's an example of inelastic collision. Okay. Okay, I'm going to stop here for a while now. There's a whole lot of things going on. First of all, this section over here is the inelastic collision. Okay, and of course, Morpheus, if you know which character this movie is from, okay, Morpheus he's not flying purposefully. There's a reason why he's flying. Okay, and if you remember the reason why he's flying, then you will know what it's called lah. Apa yang menyebabkannya terbang? What makes him terhumban ke depan? Okay, it's a very important question to ask. So don't just say, oh, he's flying because he got superpower. It's not that. Something is causing him to fly forward. Okay, and what is it? I hope you know lah. Okay, so the part where Neo comes in and flies out, okay, that's all nonsense physics lagi lah. Dia tak berkaitan dengan physics sudah. But I hope you can see the two biggest differences between elastic and inelastic collision. Okay, elastic are really everything is just bouncing off each other, and whether they move together in the same direction or move in different directions, as long as they're separate after they collide, is elastic collision. But in the case of just now, the two trucks, they were running into each other and then they stuck together after that. That's elastic collision. Morpheus flying, as some of you pointed out to me, is because of inertia. Okay, and Neo coming in to fly, and that one has nothing to do with physics. Okay, this is I hope you know what movie this is from. This is from The Matrix. It's a very old movie. It used to be very popular. Masa saya di sekolah menengah. Okay, now I feel so old. Anyway, if you've never watched The Matrix before, quite an interesting movie lah. Okay, maybe you can use this time to watch it. Okay, so let's come back to our lesson. Okay, to study, the aim of this exercise is to study the principle of conservation of momentum for explosion. You know, if you have a balloon in your house, it's an excellent example. Yes, you can go to the toilet. You don't have to ask if you want to go to the toilet. Okay, go ahead. Okay, I'm going to show you this video. Okay, somebody asked me, in my opinion, do you think a perfect inelastic collision is really possible? I want to ask, perfect in terms of what? Okay, before I answer this question, what do you mean by perfect? What is a perfect inelastic collision? Okay, I'm going to show you this video. Okay, and actually you can do this at home. If you guys have chance to go and buy balloons, okay, you can actually show the conservation of momentum using the balloon. But this example, we don't call this a collision, but actually we call this an explosion. Okay, also an example of the principle of conservation of momentum. Okay, hold on. Oh, sorry. Okay. Oh, they're slow moving this, so yeah, hold on. So I guess they blew the balloons until a certain size, and then they let the balloons go up. Okay, so what causes this balloon to go up? Okay, if you can hear the sound, it sounds like the balloon is farting. So yeah, anyway. Okay, so this is an example of an explosion because when the balloon is flying up, it is releasing air towards the back. Okay, so there's a movement towards the back of the air, and the balloon is flying forward or upward in this case. Okay, so this is an example also of the principle of conservation of momentum. Now, I want you to remember this situation when we go into class on Thursday, because on Thursday, this will come into play a lot. Okay, this example of the balloon and the principle of conservation of momentum berkaitan dengan explosion. Okay, always has to do with this. I want you to remember this. But okay, let's talk about this. So the situation is blow a balloon, then release the balloon. Okay, what happens to the air in the balloon? The answer is the air moves backward. Okay, or in this case, our video's case, the air is moving downwards. Okay, the balloon is moving out. So explain what happens to the balloon. This is the explanation. The balloon moves forward. Or in our video's case, the balloon moves upward. Okay, but notice that the air and the balloon are moving in two separate directions. Okay? This way. Oh, sorry, this way. Okay, so they were moving this way. So this is also an example of the principle of conservation of momentum. The momentum of the air that is going backwards is the same as the momentum of the balloon moving forwards. Remember, momentum is anything that has mass and velocity. The product of the mass and velocity produces a momentum. So asalkan benda itu ada velocity, okay, that thing will definitely have momentum. And air is also something yang ada jisim, okay, also has mass. So there's a certain mass of air and the air is going out. So the air will have momentum towards this direction. Okay, towards the left direction, which causes the balloon to go towards the right direction. And we find that the momentum of the air to the back is the same as the momentum of momentum of the balloon to the front. Okay? And this is an example of an explosion. So there are three types of collisions, okay? Three types of situations. We call it situations better. Three types of situations where the principle of conservation of momentum is in play. The first one is elastic. Okay, they berlanggar and then separately move. Second one is inelastic. They'll berlanggar and then after that they move together. The third one is explosion, where originally they're together and then suddenly they move in different directions. Guys, it's not possible to explode and move forward like that now, okay? They usually will move in different directions. Okay, so in this case, explosion. Okay, so the word explosion seems to cause a bit of confusion for a lot of people. Okay, it's not the explosion. Even in Bahasa Melayu, Bahasa Melayu dia dipanggil letupan. Okay, which makes it even worse because the word explode, people think of bombs and or or short circuit lah, or things like that. But no, when we talk about explosion, in terms of momentum, we're talking about the movement in different directions. Okay, bila berlaku, pergerakan dalam arah yang berlainan, we call it an explosion. Okay, I have a question from somebody. Is this also count as inertia? No, it's not counted as inertia, because inertia is this is counted as no, it's not counted as inertia, because inertia is something is already moving, you stop and then the thing continues to move. But this one is a different thing altogether. It is actually in stop. Okay, it is actually not moving originally, and then you make it move. So it's different. Okay, it's a different case altogether. It's not counted as inertia. Okay. All right. Okay, moving on. Okay, so this is another example of an explosion situation, lah. Okay, of an explosion situation where, okay, you have these two trolleys that are stuck together, okay, and they have the same mass. So if I hit this ini picu ini ya, okay, if I hit this picu, okay, what's going to happen is that the two trolleys are going to move. Oh, sorry, the two trolleys are going to move separately lah. Okay, and this is an example of explosion. Same thing like this is the balloon, okay, and this is the air. Okay, they're going to move in separate directions. So describe the motion of the two trolleys before and after the explosion. So before the explosion, both trolleys are at rest. After the explosion, and this is the important thing, both trolleys, okay, typo, move in opposite directions. This is logical because when you hit this trolley is going to go to the right, and this trolley is going to go to the left. Okay, if you hit this one and then both trolleys move in the same area, then there's something wrong. Okay, it's probably a ghost lah. Everything also ghost. Okay, so question number 2, before the explosion, the momentum of trolley A. Okay, before explosion, think about this. Before the explosion, the momentum of trolley A, is it moving? It's not moving. So since it's not moving, the momentum will be 0. And likewise, with the trolley B, since it's not moving, there's no velocity. Velocity is 0. So the momentum is also 0. Therefore, the total momentum before the explosion is 0 plus 0, which is 0 lah. Okay. So then the third question, compare the distance D1 and D2. Okay, how far do you think this trolley will travel? How far do you think this trolley will travel? Okay, actually what you will find is that they will be the same distance. Okay, they will be the same distance because of the principle of conservation of momentum, but also because they have the same mass. Dia punya GCM adalah sama. It's the same type of, same heaviness lah. So if we ignore all the other factors like air resistance and friction and everything, okay, we should be able to get the same distance. The car, let's say this trolley travels until here only, and then therefore we also say this trolley travels until here only. Okay, they should be traveling at the same distance. Okay, because they have the same mass and they are the same size and they are, they are given the same amount of force lah. Okay, but also because the momentum must be conserved. Okay, so question number 4, state the relationship between the distance traveled by the trolley and the trolley's velocity. And the distance is, the relationship is the longer the distance, the faster the speed. Okay, this is normal lah. Okay, if you can travel further, it means you have faster speed because there's nothing else except for momentum. Okay, in this plane. Based on the answer in 4, okay, compare the velocity of trolley A and trolley B after the explosion. If the distance that they cover is the same, okay, therefore the velocity must also be equal. Okay, therefore the momentum of trolley A and trolley B after the collision is also equal. It's just that they're in different directions, okay, which we will come to in a while when we start to do the calculation. But I want you to understand this situation when we talk about explosion. When we talk about the situation of explosion, the total momentum before the explosion is always 0. Oh, sorry. Okay, the total momentum before the explosion is always 0. Okay, slightly special case lah. Okay, but after the explosion, which means the car moves this way, the car moves this way, kan, we find that the momentum is equal, but the direction is different. This one momentum ke arah sini. This one momentum ke arah sini. Okay, but we find that the total momentum is still going to be zero. Okay, so the question you need to ask yourself is, if they have the same momentum, how can the total momentum be equal to zero? Okay, the answer is because one has to be a positive value and the other one has to be a negative value. So if let's say the momentum over here is 20 kilograms, oh dear, meters per second. Okay, therefore, this trolley, trolley A, it has the same momentum, okay, 20, but in order for us to make it the total momentum zero, this will be negative 20. Because negative 20 means that the trolley is moving to the left. Okay, so 20 plus negative 20, you get the total momentum zero. Therefore, the total momentum is conserved. Okay, so that's the part about this. Okay, so state the direction of the momentum of trolley A. As I said just now, trolley A will move to the right and trolley B, no, actually terbalik. Trolley A will move to the left. What? Yeah, sorry, this answer is terbalik. Trolley A will move to the left, trolley B will move to the right. But one will be positive and one will be negative. Okay, so the total momentum of trolley A and trolley B will be equal to zero because one positive, one negative. So compare the total momentum before and after explosion, and this has to follow the principle of conservation of momentum. The total momentum before and after the explosion must be equal. Must. Okay, because this is the principle of conservation of momentum. Okay, situation 2, sorry. So because of that, okay, this is the example, no, this is the actual picture of explosion. Okay, two things are joined together at first, and then suddenly they move separately because of an external force. But we still hold on to the law, the principle of conservation of momentum. Masih lagi, the total momentum sebelum pelanggaran mesti sama dengan the total momentum after pelanggaran. And then there's another formula here, which again, I'm not asking you to memorize. Okay, when we answer questions later, I hope to show you an easier way, okay, to do things. Okay, so let's take a look at this. Let's take a look at this exercise. Enough of me talking. Okay, take a look at this exercise. We have car A of mass 1,000 kilograms. Okay, moving at 20 meters per second, collides with a car B of mass 1,200 kilograms, moving at 10 meters in the same direction. So this is before. Okay, now if the car B is shunted forwards, okay, shunted means dia terboof ke depan. I don't know what is boof ke depan. Let's say after dia berlanggar bahkan, then car B is pushed forward some more. Okay, 15 meters per second by the impact. Okay, what is the velocity of car A after the crash? Okay, so this is, you need to read the question and think about which situation this is. Okay, is this elastic collision, inelastic collision, or explosion? Okay, and the key to this is what happens after the collision. Okay, so according to this question, if the car B is shunted forwards, means that this has to be an elastic collision because after they collide, after car A berlanggar dengan car B, car B moves forward even faster. Okay, becomes from 10 to 15. Okay, so I'm going to show this to you using this. Okay. So I want you to think, I want you to think this in terms of total momentum before and total momentum after. Okay, we think about this situation better. Okay, so before, okay, I'm going to simplify this. This is car A. Okay, this is car B. Let's put down all the information that we have first. Okay, so according to this, car A has 1,000 kilograms and is moving at 20 meters per second. Okay, car B is 1,200 kilograms and is moving at 10 meters per second. Okay. Now, if you remember the formula for momentum, we only move on to this. P equals to mv. Okay, mass times velocity. So this one, what is the momentum? The momentum is 1000 times 20 will be 20,000. Okay. Am I right? 1000 times 20, 20,000. Okay. And then this momentum is 1200 times 10. So it will be 12,000. Right. Okay. So what is the total momentum? This all before, belum lagi berlanggar. 20,000 plus 12,000. So the total is 20,000 plus 12,000, which is equals to 32,000 kilograms meter per second. Okay, so that's the total momentum before the collision. Okay, let's talk about after collision. I'm going to change color. I'm going to use black. Okay, so after the collision, okay, so car A and car B. Okay, so it's always good practice when you do a momentum question to state what kind of collision, so that kamu set dalam mata pula. Sorry, kamu set dalam minda kamu. Okay, adakah they're going to move together, they're going to move separately, or they're going to be exploding? Okay, so this case is elastic collision. Okay, I usually like to do this so that I'm very clear. Okay, elastic collision, they have to move separately. Okay, so we find that car A, okay, so the good thing about these guys is after mereka berlanggar, the mass does not change. Okay, if every time dia berlanggar, the mass akan berkurangkan, I want to berlanggar with everybody so that I become thinner. Okay, but the fact is, after you berlanggar, the mass never changes. So we put the mass again. Car A is still 1,000 kilograms. Car B is still 1,200 kilograms. The question is, car B, the velocity changes to become 15 meters per second. So my question now is, what is velocity of A? I'm going to call this VA okay, velocity of A. So let's count the momentum again. Sorry, I'm going to change color to orange. Okay, let's count momentum of A. 1,000 times VA will be 1,000 VA. Okay, it's okay, don't worry about it. All right, 1,200 times 15. Sorry. Okay, what's 1,200 times 50? Oh dear. Okay, 18,000. Okay, so the momentum of B after the collision is 18,000. What's my total? Okay, total is 1,000 VA plus 18,000. Okay, now according to the principle of conservation of momentum, the total momentum before, which I'm only interested in this one at the end. I'm only interested in this one. The total momentum before must be the same as the total momentum after. Okay, therefore, 32,000 must be equal to 1,000 VA plus 18,000. And this makes us very easy to cancel out VA. Okay, I move the 18,000 over, okay, and then divide by 1,000. Okay, so I'll get 2,000 minus 18,000 divided by 1,000. So after you calculate, you get VA equals to 14 meters per second. Okay, please make sure, that you're calculating this correctly, because remember, it can be 14, it can be negative 14. Okay, but the calculations will never lie. If your calculation is correct, and my calculation is obviously correct, okay, I find that VA equals to 14 meters per second. So, which means that this car, okay, walaupun dia selepas berlanggar, this car is still moving forward 15 meters per second. And this car is also still moving forward at 14 meters per second. Okay, so notice that as I said before, the individual momentums will change. Okay, the individual, ini kereta B bahkan originally 12,000. After berlanggar, it becomes 18,000. Okay, but the total momentum must always be the same. Okay, before the total must be the same as after the total. Okay, I like to do it in this way daripada saya menghafal formula. Because this one is very clear for me lah. Okay, I'm not sure if you feel that you want to use the formula, it's totally fine with me. But I like to use the before and after situation because I know the last line, okay, the very last line of both situations must be the same. This 32,000 must be the same as this one. Okay, and there's always something missing one lah. Itu yang kau kena cari lah. That's the normal case. Okay, then when you calculate, this becomes a very simple mathematical calculation. Okay, it's actually that simple. Okay, so I would recommend, but it's up to you how you want to use it. I would recommend that you do it separately and then you bring the total together at the end, rather than kau menghafal formula. Because menghafal formula for me is really, there are a lot of formulas that you need to hafal. I think this is one that you don't really need to hafal. Okay, so I'm going to share this screen again to you. Okay, we find that, find that the answer is this lah. Okay, V equals to 14 meters per second as shown. So this is if you're interested to use the formula. Okay, yada yada yada. It's faster. I know it looks faster because they sikit suggests that. Okay, but if you're very used to this formula, okay, then it becomes very fast. Correct. I understand. Okay, but sometimes some people they learn differently. So I think if you know your learning style, you should use whichever learning style that you're most comfortable with. Okay, let's take a look at the second exercise. So in this case, so I want you to read this question and tell me what collision we are talking about here now. Well, actually, you don't have to tell me that. You can tell yourself. Okay, so yes, most people are saying inelastic. Okay, obviously it's inelastic because look, the situation before, okay, the ball is coming towards this ice skater, and then after that they're moving together. Okay, so I'm going to recreate this one. Okay, so ball, and this one is a dancer. Okay, so the mass is 15 kg. The velocity is 20 kilometers per hour. 20 kilometers per hour. Do I really want to do that? Okay, fine. The mass of the dancer is 60 kg. Okay, and the velocity is 0 kilometers per hour. Okay, why is it 0 kilometers per hour? Because the word is at rest lah. Okay, this is something that we established very early on. Okay, so after they move together, so it's ball plus dancer. Okay, so obviously this is inelastic collision. Okay, so we find that the mass, okay, becomes 15 plus 60. Okay, and they move with the same velocity. Okay. Yeah, actually I feel that you don't have to change. Fine. Okay, so okay, so this one is a slightly different situation now. Okay, because the question they give us, dia punya velocity adalah kilometer sejam. We are very used to we're very used to meters sesaat. Okay, meters per second. But you see, the thing is, we are not interested in the units. Okay, the units can change, but the final unit, if you use kilometer per hour from the beginning, you can always use kilometer per hour at the end. It's okay. Okay, it's not a problem at all. So let's consider the total momentum before. Okay, the momentum of the ball before is 15 times 20. 15 times 20 is 600. 15 times 20. Okay, sorry, 300. Okay, this momentum 60 times 0 will be 0. So the total will be 300. Okay, that's before. Now, the good thing about after and the good thing about inelastic collision is since they are moving together, okay, since they are moving together and dancing together and everything, I can combine the mass together. Okay, I can combine the mass together, so the mass will be 75 kilograms. Wow, 15 kilogram ball is no joke, Can you imagine dancing with a 15 kilogram ball? if you have any younger brother or sister that is 15 kilograms, you try holding it and then try dancing around with it. Boleh ka? It's heavy, you know, okay, and yet she's dancing on ice, okay, with 15 kilogram ball. So anyway, okay, and then the other thing about inelastic collision is, since they are moving together, they must be moving with the same velocity. So the total momentum in this case is just 75 times v. Okay. Now, according to the principle of conservation of momentum, 300 must be equals to 75 times v. And this becomes a very simple calculation for us. 300 divided by 75, they are going to move together with 4 kilometers per hour. Okay, since we are using kilometers per hour dari mula, okay, we are going to move with 4 kilometers per hour at the end. Okay, so just take note of the unit that you use, you know, throughout the entire question. Kalau meter per saat lah. Kalau kilometers per hour, kilometers per hour. Okay, so this is one way to use the principle of conservation of momentum to calculate an inelastic situation. Okay, but again, like I said, I always like to count it separately and then join it together at the end. Okay, because using the formula is good and all, okay, but it can be confusing for some people. Okay, so okay, 4 meters per second. 4 meters per second. Ini lagi lah. Sorry, kilometers per hour. Okay, so let's consider this third case. Okay, a truck is moving. Yeah, I always cannot see this because of this over here. Hold on. Okay, a truck is moving at 30 meters per second, collides with a car with mass 1,000 kilogram, which is traveling in the opposite direction at 20 meters per second. After the collision, the two vehicles move together. Okay, what is the velocity of both vehicles immediately after the collision? Okay, think first. The first thing is, it is obviously what kind of collision? Elastic, inelastic, or explosion. Okay, the key word is they move together. Since they're moving together, this is the same situation as we saw just now in the matrix. They are crashing each other and move together. Okay, so the answer will be it's an inelastic collision. Okay, I'm going to give you some time. I want you to try to figure out all the values. Okay, try to count yourself, and then I'll give you about 2 minutes, okay, to calculate and see if you can come up with the answer. Okay, then we'll compare the answers together. Okay, so in our situation just now, before, okay, this lorry or the truck, okay, is moving at 30 meters per second, and the car is moving at 20 meters per second. Okay, and then after they collide, okay, they move together, okay, which is obviously an inelastic collision. Now, the most important thing that if you did not notice this, okay, then learn from this mistake now. Some people say it's 7.27. Okay, now we're going to prove it in a while. The most important thing you have to take into account now is the direction, because the direction changes the calculation a lot. We find that the lorry is moving this way and the car is moving this way. Okay? Now, since they are moving in opposite directions, the symbol for the velocity cannot be the same. Okay, I'm going to say the right is positive and the left is negative. So the separate momentum is 1,200 times 30. 1,200 times 30 is 36,000. Okay, this momentum, however, is 20,000 but negative. So the total momentum, okay, the total momentum is 36,000 plus negative 20,000. Okay, kita masih jumlahkan the momentum, but the sign has to be different. One has to be plus and the other one has to be minus. So we find that our total momentum is actually only 16,000. Okay, if you did not get this at the beginning, okay, then obviously your answer is wrong. Okay, and it's probably because you forgot to take into account the direction of the car. Kalau mereka bergerak dalam arah yang berlainan, the symbol for the velocity must be different. Okay, because all these small things will give you a very big difference. Okay, now the question is, we don't know which velocity is going, but we know that the total momentum must be the same. Okay, the total mass is 1,200 plus 1,000, which is 2,200. So I'm going to say the momentum is 2200 times v. Okay, mass times velocity. So this total and this total, according to the principle of conservation of momentum, is the same. So 16,000 equals to 2200 V. Okay, therefore V will be equal to 7.27. Okay, 7.27 meters per second. Question is it positive or is it negative? Okay, the answer is positive. So these two are going to go to the right with 7.27 meters per second. Okay, so Irina got this answer correct. Congrats to you. Okay, 7.27 meters per second. Okay, so at this point, I hope that you realize that direction is very important because remember velocity, v is a vector quantity. Okay, so direction sangat penting. Okay, things that positive and negative comes into play over here. All right. Okay, let's do another question. Same thing. I'm going to give you some time to think about this. Put all the values in, and after that we will come and talk about this. Okay. It's always good to identify what situation this is. Is this elastic, inelastic, or collision? Or explosion. Okay, once you identify it, then you know a lot of things already after that. Okay, so take some time, look through it, and then we'll come back in a while. Okay, so coming back, so thanks for your answers. Some people have given me the answers. Now, it's very important to note that this is the same case as explosion, okay? Because the most important thing is before they are moving, before the explosion happens, nobody is moving at all. Okay, they are both stationary, and the two things that are in play here is the pistol and the bullet. Okay, the man has nothing to do with this momentum thing. Nothing. It's just the movement between the pistol and the bullet. The bullet is inside the pistol, obviously, because you can't see the bullet, right? Okay, but lepas dia tembak, okay, then the bullet comes out, and then this one. So this is the same case as the balloon. Okay, like for example, the balloon is represented by this bullet, and then this one is representing the air yang pergi ke belakang. So this is the case of explosion. Okay, it's a very classic case of explosion. I'm going to write down here explosion so that I know what I'm talking about. Now, the good thing about explosion is everything before, the total momentum before is always one big at zero. So I don't have to think about anything anymore. Okay, so dua-dua pun tidak bergerak. So the total momentum, okay, the total momentum is zero. Okay, senang saja, very easy. The only problem now is the total momentum after the collision, after the explosion. Okay, so I want you to first notice that for the pistol, okay, since it's moving to the back, okay, we don't know what the value of V is. But I know that, okay, V is going to be a negative number. Sorry. Okay, V is going to be a negative number. I must expect that. Okay, so jangan takut. It must go to the left. So we know that V is going to be a negative number. Never ever put negative V begini because you're cancelling yourself out. Okay, jangan. So V is going to be a negative number. Okay, now the problem is with the bullet. The bullet is going at 300 meters per second. Fine. But the problem is it is in 10 grams. Okay, and guys, we don't play with grams anymore. We only play with kilograms. So we need to change 10 grams to kilograms. Okay, so 10 grams divided by 1,000 will give us 0.01. Okay, kilograms. So the momentum is 0.01 times 300, which is which is 3 okay, 3. So according to the, let's total up this one first. So the total will be 1.5 V plus 3. Okay, somebody. Okay, so according to the principle of conservation of momentum, this total and this total must be the same. So 0 equals to 1.5 V plus 3. Move the 3 across, becomes negative 3 equals to 1.5 V, and therefore V equals to negative 2 meters per second. Okay, which totally meets our expectations. Okay, we want V to be a negative number, but we don't put the negative so early. Okay, so negative 2 meters per second, then it makes sense. Okay, sebab dia bergerak ke belakang. Okay, so congrats to those of you who got the 2. Means you have a very good understanding of this situation already lah. Okay, so okay, let's do another situation. Yeah, today is a lot of calculations. So, all right, take a look at this question. Okay, sorry, take a look at this question. Okay, think of the situation and see how you can answer this question. Okay, we'll come back in a while. I'm going to continue. So we find that before the collision happens, okay, this is obviously an inelastic collision because after you collide, then you move together. Okay, so in an inelastic collision, you find that the mass is total m plus m, and then the velocity is apa yang kamu mau cari with respect to the shape. Okay, don't worry about it. Now, before the collision happens, we find that this guy is moving to the right now at 4 meters per second. Okay, with respect to the shape now. And you, or the second person over here, is at rest, not moving. Okay, so that's so this momentum will be 4m, and this momentum will be 0. So the total momentum will be 4m. Yes, 4m plus 0 is 4m. Okay. In this case, our total over here is 2mv. Okay, because m plus n is 2m. 2m multiplied by v is 2mv. Now, according to the principle of conservation of momentum, 4m and 2mv must be the same now. So 4m equals to 2mv. Therefore, v equals to 4m over 2m. You get v equals to 2 meters per second with respect to the shape. Okay, so we're going to find that with we're going to find that the 2 of you are going to move together to the right with 2 meters per second with respect to the shape. Okay, and this is another example of inelastic collision and how we use it to calculate. Okay, yeah. All right, any questions? Any questions for me? Any questions besides this one? Oh, kilometers per hour. Okay, fine. Kilometers per hour. Sorry, I didn't realize. Okay, it's kilometers per hour. Okay. Kilometers per hour. Okay, kilometers per hour. Okay, if in space, does the mass affect the equation? Yes, because mass is dependent on your body, it's not affected by gravity. Weight is affected by gravity, which is something that we're going to learn in 2.8. Okay. Another question that was asked of me is, if they are in space, is it impossible to stop without an external force? Yes, because since there's no gravity in space, inertia will just cause you to continue to move along the same trajectory until something stops you. So it is impossible to stop without an external force. Okay. What is this? The moment I ask a question about space, and then suddenly all this space question comes. And nobody asked me anything about the matrix video just now. So the kilometer per hour, no need to convert to meters per second. Actually, it depends on the question. Okay, now I'm going to talk about exam. The question, if this is an objective question and all the answers are in meters per second, then yes, you have to convert. Okay, but if you are given a free hand of how you want to answer, I would accept kilometers per hour, because for me, the important thing is I want to know how fast it's moving. It doesn't matter which unit to use. So it depends on the question. To the person who asked me, it depends on the question. If the question asks you to change to meters per second, then you have to change. If not, then you can just keep it as it is. Okay. Another question, sir, how is momentum related to kinetic energy? Oh dear. Okay, so momentum is mass times velocity. Okay, the formula for kinetic energy, I'm going to call it CK, is half mv squared. Okay, so it is related, okay, in a sense that if mv is momentum, I can also say that kinetic energy is half of momentum times the velocity. Okay, that's how I would say it, because mv, okay, but since it's mv squared, so I have to put another v over here, and that's how it's related. Okay, if you want, you can put as momentum is equals to the kinetic energy over the velocity times 2. But this is, totally a different Yeah, I know. It's next year's punya topic lah. Don't need to bring up this year's stuff. Focus on momentum first. Okay, because when we come to energy, it's going to be a different ball game altogether. Almost the same, but different ball game. Okay. But thank you for the question. I think it's all good questions. Okay. I like the fact that you all are asking a lot of questions. Definitely more questions than one would usually ask. Okay, but it's very good. What is E? E is energy. Okay, E is the symbol that I will usually use for energy. Different books use different. I use E lah because E is for energy. Okay, some people use T for tenaga, but for me T is temperature. So I prefer E. E is for energy. Okay. Again, guys, this is next year stuff. Okay, jangan dulu kaitkan lah. Okay? Focus on this year. Okay? All of you can't wait to be in Form 5, is it? Finish the 2 more weeks of RMO first. Okay, then talk about Form 5. Ini RMO pun belum habis, mau juga Form 5, Form 5. Okay, if there's no questions, actually that's all our class is for today because there's one whole section in the third part which talks about the application. Okay, which I don't want to talk about today because the application part, there's quite a lot of things that I want you to copy down. Okay, so if there's no more questions, I will see you on Thursday. Hold on, I'm going to stop the recording.